Alright guys, more constructions for you. This time we are constructing a square given the perimeter of the square, which means that the distance from A to B is the distance that is all around the square. So the first step is I'm going to draw a starter line and mark this point A prime, and I'm going to copy this line segment. Get our compass. I'm going to copy. I just hope my compass opens up that much. No, it doesn't. Alright, so I gotta make this a little bit shorter. Alright, let's see. Much better. Remember, we need to see that arc right here. Alright, take that compass, copy that line segment. This is B prime. Alright, so remember, what this means is that from this distance A prime to B prime is the total distance around this square. Alright? Alright. So if I want to construct this, I'm going to bisect this line segment. So, how to bisect the line segment? A little bit more than halfway. Arc on top. Arc on the bottom. Now switch to the other side. I can make the big arcs, or you can make these as you see. Or you gotta go back and fix this one. Okay. And now let's draw a line segment or a line. It wouldn't really matter. That goes through that. So the question then becomes, what did we just do? Let me call this point right here, C prime. So oops. So C prime right here. So now A prime C prime is half. That's two sides of the square. And C prime B prime is, let's think about A prime C prime as the bottom and the right side, and C prime B prime means the top and the left side. So if I'm going to construct this, that means I need to break this in half again, because a square has all sides congruent. Now I need to bisect A prime C prime and bisect C prime B prime. So let's take the compass. More than halfway. Let's do red. And sometimes you don't have to draw the big arc, because sometimes you might get a little confused. That's why I only draw what is necessary. Oops, I did it again here. Do you see where they intersect? But let's not make that mistake. All right. Let me undo that. Undo that one. There. Here we go with that line segment again. This takes practice. All right. So let's call this new intersection here D prime. And so now you see A prime, D prime is one side. D prime, C prime is a Let's do the bottom, right side. Now I need to do the top and the left. So if I take this, let me change to blue. Excuse me. There we go. All right. So we just bisected all of those lines. And let's call this new point E prime. Let me not do that. E prime. Okay. Do you see the four sections of this square? A prime, D prime, bottom. D prime, C prime, right side. C prime, E prime, top. E prime, B prime, left side. So what we now have to do, since we're going to construct it, I'm going to use either this side right here, see it? Or this side right here. I don't care which side you choose. Since we have the bottom here, now I need to do the right side, the top side, and the left side. Since they're all the same distance, I need to copy A prime, D prime, or D prime, C prime, or C prime, E prime, or even E prime, B prime, because they're all the same distance. So what we need to do is copy one of those. Let's copy A prime, D prime. All right. Let me go green on that. You see the green right here? You see this green right here? That means you copied it. This is the distance from A prime, D prime. So what we are going to do is going to put it on C prime. I'm using the left side right here. And you see where I'm marking the distance? See it? See it? Right here. And do the same thing from D prime. So you see D prime, C prime, and now you see C prime to this point right here, and to this point right there, and here. Let me mark those points. See it? Right there. and right there. I'm on what, F and G? Alright, so I got D prime, C prime, F prime, G prime. All I have to do now is construct this segment, and we are done. There you go. There is your square right here. As you see, A prime D prime is the same as D prime C prime, which is the same as C prime F prime, and F prime G prime. They're all the same distance. But if you add F prime G prime, G prime D prime, D prime C prime, C prime F prime, if you add these four sides, they should give you the length from A to B, or A prime to B prime. This is how you construct a square given a perimeter. Alright, now we are going to construct a rectangle given the perimeter. Just before we did a square, now we're going to do a rectangle. Almost the same idea, but when you see in a rectangle, we have two sides are the same length, and those two are the same length. They're not all the same length. Alright, let's keep that in mind. So first, let's pretend from A to B. I'm just pretending that this whole distance is from W to X plus XY plus YZ plus ZW. This is the total distance around this rectangle. So first, start a line with a point on there, and then we need to copy that perimeter onto this line. Let me get my compass out. As you see right here, let me get this in black. I'm copying that segment. Alright, so now we have A prime and we have now B prime. Understand that this is the total distance around. Now in a square, because they were all the same distances, we just started bisecting so we can get the equal sides. Can't do that here. So first, let's figure out ZW and XY. Remember, this is the total. So I need some distance that represents this plus this. So from A prime to some point was going to represent this distance and that distance. So we need to choose a point. But it can't be halfway, because if it's halfway, it becomes a square. So we have to choose a point somewhere less than halfway. So let's choose a point right here. Let's call that C prime. Now understand that this right here, A prime, C prime, this distance represents XY and ZW. So that means I need to bisect this guy, so I can get this side and this side to be that same length. So we need to bisect A prime, C prime. Alright, so let's take our compass. More than halfway. Top. You know what? I'll make the big arc. Alright, so what just happened now? What we did, we bisected A prime C prime right here. Let's call that D prime. Yeah, you know what? Undo that. Let me call that D prime. I don't know if you can see that or not, but it's right there. So that means A prime D prime is this distance xy. D prime C prime is this distance zy. Alright. Which leaves me from C prime B prime. C prime B prime is the distance wx and zy together, the top and the bottom. So I have to bisect that one such that I can get one side. So let's bisect it. Compass on C prime, open it more than halfway. Let's go red. Okay. So now we just bisected this guy. Right there. So we can call this point right here E prime. Put it right here. So now C prime E prime, this distance is like wx, and E prime B prime is zy. So now I need to construct this rectangle. Alright, so I need to have start at a side or a bottom. So you got to choose either C prime E prime to be the bottom or E prime B prime. It really doesn't matter. I'm going to choose E prime B prime to be this bottom right here, which means I need to do xy. Xy is the same as D prime C prime, so I got to take this and put it somewhere up here, which means I need to construct a perpendicular that goes through this point in order to get the side. So the question becomes, do we know how to construct a perpendicular from a point on the line? That would mean I need to construct a line segment, and to do that I create this arc to give me this line segment right here. This is going to be F and G. I know this is going to get a lot of letters. You got to keep track of which one is which. And so the purpose again is to bisect this line segment F prime G prime. Alright, so I want to bisect it, which means more than halfway. Let me get a different color. Let's go with blue. More than halfway. arc from here, arc from there. So now we have our perpendicular bisector. There you go. Well, it should have went through B prime, but again, right there. There we go. So now you see E prime B prime was WX. And now I have my two sides. My WZ is going to be E prime something, and my XY is going to be this B prime something. Well, which means I got to figure out what this something is. Well, that's A prime D prime. So I've got to copy that segment. Or you could have chosen D prime C prime. So let's go copy A prime D prime. I'm going to keep it in blue. Nope, I gotta open it a little bit more. And now I'm going to change colors. I'm going to go back to black. I copied A prime D prime. You see it right here? And I put it on E prime. You see it right here? E prime, and up here is A prime D prime. And oh, let me undo. Here we go. Since I chose this one, it would have been the same to go from C prime E prime, but you would have had to make a perpendicular on C prime. But there it is. You see the two intersections here and there, and all we have to do now is connect. So it was similar to the square, except you see this rectangle here? See it? The only difference is we couldn't do halfway. We had to choose a length to represent these two sides, so we called it A prime C prime, split that in half. And then C prime B prime, this was left for the other two sides. Okay, we split that one in half in red. And now all I have to do is construct, which means I needed a side. I needed a side to start on. So if I start at E prime, that could have been YX, which means I needed a perpendicular on C prime. If I start at C prime, I need to do a perpendicular bisector here. That would have been ZY. Nonetheless, I chose the point B prime to make a perpendicular bisector. Remember, we need to create an arc to get the segment and then bisect it. And then all I have to do is copy this side, which is A prime D prime, right here and right there. We're on H and I. So this is H prime. That's this point right there. And I prime which is that point right there. So sometimes it's better to do with color pencils when you're doing the square or the rectangle. Now to apply everything that we learned in construction, one of the things is called the point of concurrency. Here we have 4 different types of points of concurrency, and in each type there are 3 different types of triangles that we need to do it for. I'm only going to demonstrate the acute triangle for all cases, but the procedure is the same for all different type triangles for the acute, obtuse, or right. So first we're going to talk about the incenter. And the incenter is better known as the angle bisectors. So here's an acute triangle, meaning all the angles are acute. Obtuse, one angle is obtuse, and a right, one angle that is a right angle. But nonetheless, this is an angle bisector, which means I need to bisect angles. Well, it goes back to your construction. Do you know how to bisect an angle? Well, if you don't, it's the arc method. Remember that? So I'm going to take the compass. I'm going to bisect angle C. I'm going to put the pointy on C, open my compass, I don't care how much, and create an arc. Remember, you guys have problems with this because I used to get arcs right here. If this is the span, do you see the intersections right here? I'm going to put it on the intersection right there. Make an arc right here. And now the intersection right here. Make that arc. And then I'm going to go from the vertex to the opposite side. Right there. Okay. So we know that this angle here is the same as this angle. Let me call this point right here D prime, D. Okay, so now this is D. This is one angle bisector. We're going to repeat the same process, but now we're going to do it for B, and we're going to do it for A. Alright, so let me change colors. Let's go red. Angle bisector time. I'm going to go a little bit in. I'm going to bisect angle B. You see those two intersections right there. Okay. Intersect there and here. Connect. Right there. So I'm going to call this point E. Okay. We did angle C, we did angle B. Now what we have to do is angle A. Let me change colors. And I'm going to bisect this angle. Now I can keep it the same, or remember, you can open it as much as you want. Arc on the inside. Arc on the inside. And let's connect. So let's call this point right here F. Okay. Now, the whole thing about these in center is where all the three angle bisectors intersect. This is an acute triangle, and you see they intersect on the inside of the triangle. here is the incenter. Let's call that G. Alright. So right here in an acute triangle, in this acute triangle, we say that it's on the inside. So your goal is to figure out what happens in an obtuse and a right triangle. Where is this incenter located at? So in an acute triangle, this incenter, or the angle bisectors, happens to be on the inside of the triangle. Our next application is the circumcenter, or better known as the perpendicular bisectors. Again, you have to figure out what happens in obtuse and right. I'm doing the acute scenario. So it says to do the perpendicular bisector. So if I have three line segments here, line segment AC, line segment BC, line segment AB, I need to bisect it. Well, this should be simple. All we have to do is bisect. Let's bisect line segment AC. Again, you should know more than halfway if you want to create. This can get messy, so color pencils probably is a must on this one. We're going to go from this side and that side. Right there. Alright, let's go with this green. So I know you probably can't see it down here. If I back up just a little bit, maybe like that. So this point right here bisects AC. It is also perpendicular to this segment. So let me mark that point. Oops. Undo. Let's mark that D. Okay, so here's a perpendicular bisector. Now we need to bisect AB. Alright, so let's bisect AB. Let's take this compass. More than half. Let's change colors. Let's go reddish. And again, from this side, from this side, and now let's figure out where that is. You see I'm extending it because I need to see where it goes. So let's call that point right here E. Oops, I thought I got it. We're on E. That's point E. Alright. Again, this spread is perpendicular and it bisects AB, which means AE is the same distance as EB. And AD is the same distance as DC. But AD is not the same distance as AE. So that'll be like one tick mark, two tick marks, two tick marks. And now left is just B and C. Alright. Let's see if my compass can open up that wide. Because remember, we need it more than halfway Yeah, we can. Now let's change the color to blue. You see, if you can't keep track of which arc it is, especially if you're doing it in just regular pencil, you gotta make sure. And sometimes these can go outside the paper, so you gotta be careful with that. There it is. For B and C, it's these 2 points right here. Alright, let's see if we can get that. Right there. We're on F. Let's mark that point here as F. Okay. Did you notice anything? Look at the blue, the red, and the green. Oh look, they meet in here. So in an acute triangle for a circumcenter, which are the perpendicular bisectors, they still meet on the inside. Oh, so let me paste right here. Now the question is, why is the circumcenter important? Well, hold on. Let's get that G in there. And the reason why we call it a circumcenter is because the distance from this point to each vertex from G to B is the same distance as from G to A, which is the same distance as from G to C. So they actually apply this in malls. Have you ever wondered where they put the food court at? Well, they look at their three largest places and they find the same distance, because they want people to walk from here to here, the same amount of walk from A to G and from C to G. This is where circumcenter is being used. Our next construction for points of concurrency happens to be the centroids, or the medians of the triangle. Medians, middle. Centroid, center of things. So first, we need to bisect these three line segments, AB, BC, CA. You might be saying, but isn't that the same thing that we did with the perpendicular bisector? Somewhat, but it's just a little bit different. There's this tiny difference with the medians versus your circumcenter. Alright, so let's bisect CA more than halfway. This is why it's so crucial that you know how to do these things. Alright. Yes, this is the perpendicular bisector. This is point D. Oh, you know what? Hold on. Let me paste that point. So this is point D. Okay. Again, I'm going to do now A, B, and B, C. I'm just changing the colors. Let's go red for AB. more than halfway. Again, color pencils is probably a must. And this will get easier once you start knowing how to construct these basics. Right there. Let me call that point E. Okay. And now I got one more to do, and that would be BC. And let's do that in blue, or let's do green. More than halfway. You know, if you want to create circles on each one of these, that is fine as well. You'll see some nice, interesting things coming out of all this. Alright, so here's the point, here's the point. Let's do this green. As you see, this is where they still intersect in inside, but here's what medians are. Hold it. Let me put that point on the inside, and let's do this point again too. We're at F for that point, point F, and where they meet on the inside is point G. We have to focus on this point G. Now I know the circumcenter was the distance from the circumcenter to each vertex are the same. Okay. So right now, for the medians are from the vertex going to the center, from the vertex going through the center. So I'm going to do that in blue. Let's do blue right now, so you can see it. From the vertex, you see it right here? See the blue? Vertex. Do you see it? Do you see that? Oops. I should have went from the vertex to the midpoint. My apologies on that. From the vertex to the midpoints. Sorry. Do you see the blue from the vertex to the midpoint, vertex to the midpoint, vertex to the midpoint? Do you see this one right here? Right there. This is where all the blues intersect. This is called the centroid. Right here. You know what? Let me do a circle. Let me fill it with blue. And let me move that right here. This is where it's all about. So we had to bisect to figure out where the midpoint is for each segment, and that were points D, E, and F. We constructed you can call the perpendicular bisector or the bisector of that segment. But from the vertex to that midpoint, vertex to the midpoint, vertex to the midpoint, that what makes a centroid and a circumcenter different. Remember, circumcenter was from G to the vertex. So where is this used, these medians? This is where you balance things out. If you ever wondered how circus people balance plates or balance a person or whatever, they find the centroid, the very center of that object, and you can balance it. You can balance this triangle. See this triangle? If I cut this triangle and put a pencil right here, I can balance this triangle, and I can walk around with it. So this is what centroids are being used for. They're somewhat like perpendicular bisectors, somewhat, just a little bit different. We have come to the last type of point of concurrency, and that is called the orthocenter, better known as the altitude, the height. Again, I'm only doing a cute triangle for right now. So I need to find the altitude, which means the altitude is the perpendicular distance from the vertex. Which means, let's pretend we're talking about B right here. I can't just drop any line. I need to drop a perpendicular from B to the other side, which then becomes the construction of how do you construct a perpendicular with a point not on the line. So I'm going to assume my line is AC. I'm assuming that, and my point is B, and now I got to construct a perpendicular from B to this line. So our first step is you might, and again I say you might need to extend the side. So all I'm going to do is extend this side right here. And the reason why I'm doing that is because if I put my compass on B, I got to create a segment in order to bisect it, to get a perpendicular through it. So if I put my compass there, the segment might be like this. So I am extending this side for right now. I'm going to get my compass, put it on B. Here's the point, not on the line. Do you see what I'm saying? Let me see if this is going to work out for me. Yep. You see this arc that I'm about to make? This arc right here gives me these 2 points. Let's call those D and E. I'm not going to put the points, I'm just going to name them. D and E. See it? Where they intersect? And now I have to bisect this segment DE. I'm going to keep it in blue so we know we're talking about that. So to bisect it more than halfway, you see it? Here. Between D and E, this is that segment, this is more than halfway, and now I'm bisecting that segment. And now we should be good. You see it? This is from the vertex right here, makes a 90-degree angle. So I'm going to call that F. Okay. Well, I have to repeat this process 2 more times. That was from point B to the opposite, because B was the vertex. Now, let's pretend A was the vertex. Let me change colors first. Let's go green. If A was the vertex, which means the line must have been CB. Let's see, would I create? I can create an arc right here. See it? No. Which means I have to extend CB. So let's extend CB. Alright. So now I can create that segment. You see now I have these 2 endpoints here. Let's call this G and H. And I got a bisect line segment GH. Okay. So here we go again. That's this. So the good thing is when you have color is that you know where to look. Alright. Do you see right here this point? It's from the vertex to right here. You see the blue? Vertex to right here. Green. Vertex to right there. Let's call that I. AI is the altitude for this side. PC, and BF is the altitude for AC. So I did this side, I did this side. Now I'm left with vertex is at C. Let me change colors. Let's do red. If I do at C, and I need to get to this AB, you see it? Either I can draw it down, oh my god, no matter what I do. Let me see if I can make it smaller. So no matter what I do, I have to extend that line. So, okay, let's extend that line. Let's just do it up there. All right. Look at the red now. Which means I should have extended it down there as well. Lesson learned, lesson learned. Problem with this is you have to use your straight edge to make sure it's a straight line. But here we go. This point here and this point right there. Yeah, this is messy, and it will be messy. bisect that segment. More than half. Okay, that's that segment, more than halfway, somewhere around here. Again, the beauty of color pencils. Okay. Okay, so now, if we try to erase everything and focus on the vertex, the three vertices, and the lines that they draw, from here to here, from here to here, and from here to here, they meet right over here. Okay, so let me make a circle a little bit bigger so you can see where they meet. Right there. That's the orthocenter. Okay. Alright. This was the last of the constructions in Chapter 1. Wait to Chapter 2.